Okay, so this is the 2024 Science Double Award paper. So blank page to start off, lovely. So first question says, Karis and Pavel prepared some crystals of zinc sulfate reacted with zinc carbonate with an acid. Give the name of the acid they used. So sulfate, so we need to be thinking sulfuric acid. Give the observation immediately shows a reaction is taking place, fizzing and bubbling. It's the CO2 from the carbonate. Remember, whenever I see that word, that carbonate, CO2 from the carbonate, which is causing that. State why excess zinc carbonate is used to ensure all the acid is used up. Describe the remaining two steps. So this is the dissolve step. And then we've got the filter to remove excess zinc carbonate and then the evaporate to remove water. Give the chemical formula of zinc sulfate. Remember, that is in your table of ions, which is on the back page. Zinc is 2+, SO4 is 2-, so they balance out. Next thing, we've got some nice data. And then on the next page, we are going to plot a graph. Only a couple of steps because the end bit had been drawn for you. Okay, it says draw a straight line. So they gave you the idea of a straight line. That intersects kind of means so that they overlap, and you can see there's that point of overlap there. Okay, nice 3 marks. So it's kind of 3 points. Use your graph to give the temperature that would have been recorded when 15 centimeters cubed of acid was added. So you can see there I've drawn a nice, it hasn't come out very well, drawn a line up and a line across, and I got 24.9. There would be a slight little bit of deviation if you needed it because of how you've drawn your line, but that one's come out you can see quite well at 24.9. Karis and Pavel concluded that the volume of acid needed to neutralise all the sodium hydroxide solution was somewhere between 20 and 25. Use the graph to give the exact volume. So you're looking at where your point overlaps. And again, you can kind of see my line there at 21. But again, there might be a little bit of slight deviation based on how you draw your lines. But you're looking for that point where they overlap, which would be the exact volume needed. Tick the 2 improvements to the method that would enable Karis and Pavel to obtain results closer to the expected values. So you're looking at insulating it because it's a temperature experiment, and then place a lid. So both of them are insulations because you want to limit heat lost. Okay, most of the other ones are kind of not really something that would improve your results. In a different experiment, it's found that the maximum temperature reached was 40 of hydrochloric acid, 40 centimeters cubed of hydrochloric acid, and 20 of sodium hydroxide solution. State what this means. HCl is in a lower concentration than NaOH because it's a larger volume. So what you want to be thinking is that second sentence that I've written there. The larger volume means it's a less concentrated solution. Oh, another blank page. Oh, look, it's the blast furnace. A diagram shows the blast furnace is used to extract iron from iron ore. One of the reactions inside the furnace is the reaction between carbon dioxide. So straight away you want to be thinking CO2 and carbon to give you carbon monoxide. So they kind of gave you, they are symbols that you should really know. And it does, as you see, I've put a 2 there to balance it out. So you would have got 1 mark for writing the symbols and then a second mark for balancing it out. Or another balance in the question, and the if in doubt, write 2s doesn't work, okay? What you're looking at here is that there's no box in front of that. So that has to be 3 carbons, which means that number has to be 3. So that kind of gets you started there, okay? So then you know you've got 6 oxygens. So you make sure on this side now I've got 6 oxygens. And then the last bit then will give you the 4 ions. There was a lot going on there for 1 mark, okay? All that balancing. Explain why the reaction shows oxidation and both reduction take place. The coke is gaining oxygen, so it's oxidized. The iron oxide is losing oxygen, so is reduced. So you can see oxidization taking place there, like we've practiced in class. And you can see reduction taking place there. Okay. Complete the name for the type of reaction stage 1. It's thermal decomposition. So that's just a fancy word for saying heat to break something down. and give the formula of calcium siligate. Okay. Now, because it's a single product, all you had to do was add them together. Okay. So you started off, if I just put them all together as one compound, and then I've just tidied it up a little bit there. Then these are loads of alkanes and alkenes, so I'd be looking, thinking that's an alkene, alkane, alkane. So you can see anything with a double bond would be an alkene, and then they're alkanes as well. I'm just trying to do that a bit quick for you. And then that's an alkene. That would be what I would see if I was doing it, just making sure I know everything that's going. Okay, so that is the general formula for an alkene. So any of them on the previous page I've said an alkene with a carbon-carbon double bond would give you that answer. Number of compounds that are saturated. Okay, so they have no double bonds, so you could count them, anyone that have got alkene. And then the compound with but-1-ene, so a double bond on the first carbon. So 1, 2, 3, 4 on the first carbon. Draw a structural isomer of C5H12, not shown. So I've just drawn a long chain one. And then describe the chemical test between C and D. So expected observations, add bromine water. D's got a double bond, so it's going to go from orange to colourless. C stays orange. Then this is a alkene. It's an alkene that's used to make plastics, PVC, which we know about. Explain what happens during the formation of PVC and draw the repeating unit. Okay, so the first thing I'm going to just look at really quickly is the repeating unit. Okay, the repeating unit, you remove the double bond, kind of straighten it all out, and then write it out and then put a little N. And then this is kind of the basis of cracking, which we've learned. Small reactive monomers, remove the double bond, form long chain polymers, monomers joined together. Apart from cost, suggest 2 reasons why PVC has been replaced by iron. So it does not rust, it's waterproof and unreactive. Oh, another blank page. Nice little bit of bond in here. Okay, first thing I should be doing, like we do every time, that's a metal. That's a non-metal. They've even given you the groups they are in. So group 2, group 7. So I can draw my outer shells. Okay, we would have started off maybe by just drawing this one fluorine, and then knowing that we need to transfer one across, so that's got full outer shell now, but I've still got one here on my calcium, so I draw another one. Remember, when I've got this, I know that's ionic because it's a metal to a non-metal. Then I've given their new electron structures. If you notice in the question, it says to include electron structures and the charges of the ions. Calcium oxide has a higher melting point, so calcium is 2+, oxide is 2-, potassium is plus, chlorine is minus. So there's a larger charge, which means there's a larger electrostatic attraction. Remember, we've talked about, if we wanted to, we could draw like one line here, just to think of that's the charge. And then this then, larger, it's harder to break. Okay, so when you're melting something, you need to break these bonds. So it's harder to break, more energy to break the bonds because there's a bigger attraction, a bigger bond, okay? But you need to make sure you write these buzzwords, electrostatic attraction. And then last little bit on this question is a difference between diamond. And I don't like how this diamond questions come out because we need to make sure they're all kind of connected together like that. And graphite, remember graphene is one single layer. Graphite is all the layers. Graphite is layers, whereas diamond is a tetrahedral shape. Graphite has 3 carbon bonds and diamond has 4 carbon bonds. So there's kind of the 2 answers they were looking for there to compare them. Remember, graphite is a lubricant, the layers slide over each other. You could have, could have said something about that. This one, it says the difference in the structures. It doesn't say in the properties, so they wouldn't be asking for things like conduct electricity. The photograph shows what happens when the copper coil of wire is placed in silver. I've obviously taken this from a copied one, so you should be able to see colour on yours in the actual exam. Explain why the solution turns blue. Copper is displacing the solution. Copper nitrate is forming. Silver is being displaced. Okay. And then it asks you to do a balancing equations. You had to form the symbol of copper. So copper is 2+. Nitrate is 3-, so you want to do top, swap, drop. So at the top, Cu2, NO3, 1. Remember, it's a 1. Ignore that 3 down the bottom. Swap them over, so Cu1, NO3. 2, drop them down, so Cu1 technically, NO3, 2, like that, okay? And you've got lucky there. If in doubt, put 2s in the boxes, because there's 2 marks, 1 for forming the ion, second one for balancing. It then goes on to ask you for the ionic equation. So you're looking at what would form this, okay? You're also looking for the one that's aqueous because they're in solution. They aren't solids, okay? They're in solution and they're forming a solid, okay? And it tells you there it's a white precipitate, which means you're forming a solid, okay? By here then, the colour of the precipitate shown is when silver nitrate solution is mixed with sodium iodide. So we're looking at the iodide. This is year 10, okay, silver nitrate. So it's going to be yellow because it's iodine. That comes with the chlorine that's white and the bromine that's cream. Some lovely now reading for you to do. And then there's some kind of tick in the boxes. Okay, I started doing crosses and then I just decided to put a tick for the one that I needed. If you read through the information, that is the correct answer there. Bioleaching conserves supplies of the lowest grade metal ores. State whether you agree with the following statement, give a reason for your answer. Phototomining mining and bioleaching both include biological processes. I've put agree, both involve biological species, plants and bacteria. So that's thinking about biology there, but they talked about different species that they use. Suggest a reason why photomining might not be suitable for method for extracting metals in some countries, even if they have supply of low-grade metal ores, requires plant growth which won't happen in non-sunny countries. Although effective in extracting copper, suggest a reason why bioleaching is an extremely slow process. Bacteria feeding takes a long time. You have to wait for each leachate to form. Explain why iron can be used in the last stage of both of the methods of copper extracting. Iron is more reactive than copper. I think that would have got you 1 mark. You should have been able to say then iron will displace the copper. Then there is a empirical formula question, which again is year 10. So you take the mass of both and divide it by the MR. They gave you the MRs, okay? Then divide by the smallest. So we're on about 5 marks for year 10 content, which is something to be quite wary of, okay? And that was quite nice. It gave us whole numbers. So you need 2 coppers for every 1 oxygen. And finally, this is kind of the content that you would have expected to give in the 6 marker. So crude oil is a complex mixture of hydrocarbon compounds with a range of boiling points. The more useful products from fractional distillation are called fractions. Crude oil is boiled. They would have accepted vaporized or evaporated before it enters the fractioning column. Fractions condense at different heights inside the column because they have different boiling points. The higher the boiling point, the lower down it condenses. You could have done it the other way. The boiling points are linked to the length of the carbon chain. The longer the chain, the higher the boiling point. Compounds in the same fraction have similar boiling points. And then additional page, you did it. Table of ions, like I mentioned a couple of times throughout the paper. And the periodic table.